Okay guys, this lesson we're going to learn two forms of factoring. The first one's going to be the most important because you have to check it for every single factorization question. Okay, and the second one's going to be a lead on from the last lesson when we had those expansion patterns. Okay, so let's just get started here. So it says factorizing expressions by finding the HCF. So that's the first thing we're going to do. Now before we get into it, guys, we need to realize that what algebraic expressions are. And they're made up of terms separated by plus or minus signs. So in that first little thing there where it says 4xy plus 3x minus 4y, that is an algebraic expression. If we then set it equal to something, that would make it an algebraic equation. But since it's not equal to anything, it's just an expression. And that is made up of three terms. Okay, we can see here that the three terms are 4xy, or positive 4xy. We also have a term of positive 3x, and we also have a term of negative 4y. Now, so that's just to clarify what a term is and what an expression is. Now, we also need to realize that factorizing is the opposite of expanding. So if I start with 3 times 3a plus 2, that is what's called a factorized expression. And I can expand that. Okay, and so I just multiply everything outside the bracket, outside the bracket by everything inside the bracket. So I do 3 times a and 3 times 2, which gives me 3a plus 6. But then if I want to go back, that is called factorizing. So if I want to go from 3a plus 6 to 3 times a plus 2, that is called factorizing. Now, to factorize an expression, we must find the HCF, and the HCF is the highest common factor. And we need to find the HCF of all the terms, and what we do is we find the HCF and then we write it down. Okay, and that is for both the numbers and the letters. Then we need to start a bracket beside the HCF and divide the HCF from each term one by one and place this result inside the bracket. Now we have to be very careful with signs, and we need to check by expanding. Okay, so let's get to it. Okay, so we have 5x plus 15y. So I ask myself, is there a number that divides into both 5 and 15? Yes, 5 does. So we say equals 5. And then I ask myself, is there a common letter? No, there's not. So the HCF is 5. So I've written it down, and then I open a bracket, and then I ask myself, 5 times what gives me 5x? Well, that is x, because 5 times 5x is 5x. What do I multiply 5 by to get 15y? Well, I multiply it by positive 3y, because 5 times positive 3y is positive 15y. So that is factorized. Okay, so let's do the next one down here. So we have negative 14xy minus 4y. So what number goes into negative 14 and goes into negative 7? Well, negative 7 does. Now guys, technically you don't need to have the negative, but it is better to do the negative since they are both negative. Okay, is there a common letter? Yes, there is. Y. So we write that down. Negative 7y times what gives me negative 14xy? Well, that's 2x, because negative 7y times 2x is negative 14xy. Negative 7y times what gives me negative 7y? Well, that is positive 1. Okay, so that's factorized. Now, we can have more than 2 terms. So here's 3 terms. 15ab minus 21bc plus 18bf. Is there a number that divides evenly into 15, 21, and 8? Well, it's obviously not 2 because I have some odd numbers. It could be 3. So if I write the multiples of 3 down here, let's see what happens. 3, 6, 9, 12, 15, 18, 21. Okay, so 15, 8, and 21 are all multiples of 3. So that means 3 will divide into all of them. Now, boys, you don't need to do this if you can do it in your head. Okay, so you might have seen straight away that 3 goes into all of those. Now, is there a common letter? Yes, B. Okay, so 3b times what gives me 15ab? Well, that's 5a. 3b times what gives me negative 21bc? Well, that's negative 7c. 3b times what gives me positive 18bf? Well, that's positive 6f. Okay, next one. Is there a number that divides into both 6 and 9? Yes, 3 does. Is there a common letter? Yeah, X. Okay, is there a common, what about Y? Yeah, there's Y's in both of them. Okay. Now, 3xy times 6x squared y, let me start again. 3xy times what gives me 6x squared y? Well, that's 2x. 3xy times what gives me 9xy squared? Well, that's positive 3y. And that's factorized. Okay, now let's look at this next one. We have 3 times x minus y plus 5 times x minus y. Well, guys, both the 3 and the 5a are being times by x minus 1. So, x minus 1 is a common factor. X minus 1 times what gives me 3 times x minus 1. Well, that's 3. X minus 1 times what gives me 5a times x minus 1. Well, that's positive 5a, and that's factorized. Now, let's look at this one. We have 4 terms here. Okay? We have 2a squared plus plus a cubed minus 4b minus 2ab. Now, there's no common numbers, there's no common factors for all the terms. Okay? Because, 2 goes into 2, 2 goes into 4, 2 goes into 2, but it doesn't go into 1. So technically you can do 1 into all of these, but that doesn't help us. Okay, there's no common letters for all of them. Okay, there's 2 a's here, but the last 2 terms don't, the middle term doesn't have an a. So there's no common letters for all 4 of them. So what we're going to do, guys, is we're going to break it into 2 bits. Okay. So what can I factor out of 2a squared plus a cubed? Okay, well, there's no common number, but there's common letter. And we have a common a squared. So a squared times what gives me 2a squared? Well, that's 2. A squared times what gives me a cubed? Well, that's positive a. Okay, now let's look at the second one. Negative 4b and negative 2ab. Okay, there is a common number, and that's negative 2. And there's a common letter, B. So we ask ourselves, negative 2b times what gives me negative 4b? Well, that's positive 2. Negative 2b times what gives me negative 2ab? Well, that's positive a. Oh, and look, we have the same situation as the last question. So we now have another common factor now. So that's 2 plus a. Okay? And then it's going to be times a squared minus 2b. Because 2ab times a squared gives me a squared times 2ab. 2ab times negative 2b gives us negative 2b times 2 plus a. Alrighty. Sorry guys, just going to smash through this. Okay. Now, guys, actually, what I want you to do now is I want you to pause the video, and before we keep going, guys, I want you to do, let me see here, just skip forward, just ignore this. ignore this, guys. What I want you to do, because we'll come back and do this together in a second. Guys, I want you to do, right now, pause the video, I want you to do these ones. Okay, 1 AC and 2 AC. Okay, the answers are in your booklet. So give those a go, then pause the video. Okay, guys, so you finished 1 AC, 2 AC. Hopefully you had some success. Okay, now let's look at the second bit of this lesson, which is factorizing two-term expressions. Now, to understand this, guys, we have to go back and look at expanding difference of squares. So if we have, remember, guys, if we have a plus b times a minus b, okay, what do we get? Well, if I used FOIL, you don't have to write this down, guys, but if I used FOIL, a times a is a squared. A times negative b is negative ab. Positive b times positive a is positive ab. Positive b times negative b is negative b squared. So those cancel, and we're left with a squared minus b squared. Okay? So, if I have a plus b times a minus b, I'm left with, if I expand, I'm left with a squared minus b squared. So remember, expanding is going one way, factorizing is going back the other way. Alright, guys, so we can use knowledge of that pattern to go the other way. Okay, so we use these patterns to expand expressions, now we use the same patterns to factorize expressions. So if we see that we have a squared term separated from another squared term by a minus sign, we know that factorized is a difference of two squares. So a squared minus b squared will equal a plus b times a minus b. Okay, so let's do some of these on our own. Now, let's look at x squared minus y squared. Okay, now, do we have a common factor? Is there a number that divides into both of the numbers? Well, there's no numbers there, so there's no number common factor. Is there a common letter? There's not. So now we look at the number of terms. We have two terms, and they're two terms that are square terms, and they're separated by a minus sign. So we know it's a difference of two squares. Okay, so it's going to be x plus y times x minus y. That was an easy one. I always do the positive term, the positive bracket first, because I'm a positive type of guy. Alrighty. So let's factorize 4c squared minus 9. Is there a common factor for the numbers? No, there's not a number that divides into both 4 and 9. Okay. Is 4c squared a squared term? Well, it is, because I can take the square root of it. The square root of 4 is 2. The square root of c squared is c. So the square root of 4c squared is 2c. 2c times 2c is 4c squared. Is 9 a squared term? Yes, it is. I can take its square root. The square root of 9 is 3. So it's going to be 2c plus 3 times 2c minus 3. And you can check that your answer by expanding if you want. Now the next one, 49 minus x plus 1 squared. Okay, is 49 a squared term? Yes, it is. The square root of 49 is 7. Okay, we've got a minus sign, so that's good. And then we have x plus 1 squared. Can I take the square root of x plus 1 squared? Yes, I can. It's just x plus 1. Okay, so I'm just going to do this one by hand. Oh. Okay, so that's going to equal, okay, square root of 47. Sorry, the square root of 49 is 7. Okay, the square root of x plus 1 squared is x plus 1. Okay, that bracket's important. You'll see in a second. Okay, then I put the minus. Okay? Now, I can, because there's a positive sign out in front of this bracket, I can just get rid of the bracket. But this one, because there's a negative out in front of the bracket, I have to change the sign or give the negative to each term. So that's minus x minus 1. So that's going to be x plus 8 times negative x plus 7. Oh, sorry, plus 6. My bad. Okay? Because the x is negative, I put that to the front. And then I have 7 minus 1, which is 6. Okay, let's do the next one. Is there a common factor? Okay? Does 3 go into 48? Yes, it does. It goes into 48 16 times. So I do the highest common factor first. Okay, so I factor out the 3 first. So 3 times t squared gives me 3t squared. 3 times negative 16 gives me negative 48. Now, inside the bracket, can I do difference of 2 squares? Well, t squared is obviously a squared term. 16 is a squared term because the square root of 16 is 4. So this equals 3 times t plus 4 times t minus 4. Okay, next one. Is there a common factor? Okay, 2 goes into both 2 and 8. There's a common m. And there's a common n. Okay? 2m times n, 2mn times what gives me 2m squared, cubed n, and that's n squared. Sorry, m squared. 2mn times what gives me negative 8mn cubed. Well, that's negative 4n squared. Okay. Now, I've got difference of 2 squares. Okay, the square root of m squared is m. The square root of 4n squared is 2n. So I have m plus 2n times m minus 2n. Okay, and that is factorizing two-term expressions using the difference of squares. Okay. Did we do these? Okay, yep. Alrighty. Now this one here, if we do 4-term ones, we've already actually done 4-term ones in an early example. Okay. So we break these up. Well, first thing we do, sorry guys, is we look for a common factor. Is there a number that divides evenly into 2, 8, 1, and 4? Well, 1 does, but that doesn't help us. Is there a common letter for every single term? Well, no. Okay. Not every single one has a common letter. So what we do is we break it up into 2 bits. Okay. Is there a common number for 2 and 8? Yeah, that's 2. Common letter, no. So if I factorize 2x minus 8y, I get x minus 4y. Okay, I do this the next 2 terms. Is there a common number? No. Common letter? Yes, m. So I say plus m. Okay, m times what gives me mx? Well, that's x. M times what gives me negative 4my? Well, that's negative 4y. And then notice, guys, we've got a common bracket. So we say x minus 4y times the numbers out in front, which is 2 plus m. And guys, if you want, you can check by expanding. Okay, so if I did 2 minus 4y times 2 plus m, guys, this is just a check. You can do this in your head. FOIL. X times 2 is 2x. X times m is positive mx. Negative 4y times 2 is negative 8y. And negative 4y times m is negative 4my. Okay? And guys, we can rearrange it to look like that. So we can make it say 2x minus 8y plus mx minus 4my. So these two are the same. Okay, let's do the next one. Can I do a common factor for each 4 of these? No, I can't. Okay, so now we break it up into 2. Okay, so that gives us x times x plus 3. Okay, this time, guys, I'm going to factor out positive y. Okay, now guys, this is good, okay, because I didn't stop and look. Now, what happened here, guys, is notice my brackets aren't the same. Okay, so that's not good. Okay, I need my brackets to be the same. So I'm going to have to get rid of this. I'm going to have to start again. All right, guys, so I'm starting again. So here, guys, I need to make it so I get a common bracket. So what I'm going to do is I'm going to group my x squared and negative y squared together. As, guys, remember, as long as we keep the sign to the left of the term with the term, I can move them around. So I'm just going to rearrange it. It's like collecting like terms. Okay, so plus 3x plus 3y. Now, for these ones here, what do I have? Well, that's a difference of squares. Okay, so that's going to be x plus y times x minus y. And then for the next two terms here, I can factor out positive 3. Now, I've got a common bracket of x plus y. So I'm going to say that equals x plus y times x minus y plus 3. Okay, that's as hard as these ones are going to get. All right, guys, so that is factorizing 2 and 4 term expressions. Okay, good luck with the homework.